All right. Well, in our last class, we looked at finding slope using the formula rise over run. And now we're going to, again, relate back to rates of change or unit rates, as you might want to say. And one example is if we use a distance time graph, the speed of an object can be found by finding the slope of the line on the graph. And so, for example, one here, the graph shows how the distance of a car changes over time during a trip. Find the speed of each vehicle in kilometers an hour, represented by the graphs by finding the slope. So we're going to find a rate of change by finding slope. And so again, the key thing here is when you're finding slope is that you want to have two good points. All right, so where you're not guessing, they're not decimals. And so I'm going to pick the first one, the last one here. And you can see on this graph, first off, that's a 1 there, by the way. It's kind of blending in. That each block isn't worth 1. And so you have to pay attention to that when you're doing the slope. And so in this case, I'm going to move over, and I'm not going to bother counting spaces because right there, now I'm at 1. Now I'm at 2. Now I'm at 3. And now I'm at 4. And now that we're doing rates of change, the units are important. And on my run or on my x-axis, the time is in hours. And then I go up to my next point, to my blue point. And again, it doesn't matter. I'm not going to count the dots because I look over. And I was at a height of 0. And then I move over here and I'm at a height of 300. And so if I'm going from 0 to 300, I moved up 300. But again, the rise values, I look at my units here, and this is the distance, but the units are kilometers. And so now I can divide my two numbers, 300 divided by 4. Let's see here what I end up with. I get 75. And the units, again, this is something we looked at with unit rates. Kilometers are on the top. Division means per. And we have hours on the bottom, or hour, because it's a unit rate. So this person's going 75 kilometers an hour. All right. Next one. We have time of the day. So again, that's in hours, and our distance in kilometers. And so again, I'm going to pick 2 points. I might as well pick this one and the last one like I did before. All right, so now I'm finding my slope. And let's see here. So I move over. This time every hour is 2 spaces. So there's 1 hour, 2 hours, 3 hours till noon, 4 hours, 5 hours, 6 hours across. All right, now when we look up, we're going up here. So again, the spaces are not 1 each, so I don't bother. Now I look at my graph here. That's 10 there where that starts. All right, and we go across here. It's in between 120 and 110, which is 110. And so our rise here is if you're going from 10 to 110, again, you just find the difference. And it looks like 100. And again, our units are kilometers. And so now I take our 2 numbers and divide them. All right, so I take 100 and I divide it by 6. And this person is going 16.67, again, kilometers per hour. Hopefully that's somebody on a bike, or it could be my wife driving. All right. Here's another look at rates. Jimmy took 15 minutes to drive 30 kilometers to attend a soccer tournament. What is Jimmy's speed for the trip in kilometers per hour? All right, so we're again finding speed. Now, it's taking 15 minutes to travel 35 kilometers. Now, this is where your knowledge of hours takes over. But if not, if I add 30 minutes or add 15 minutes, I should say, I'm up to 30 minutes. Now, in terms of my kilometers, if my rate is 35 kilometers per 15 minutes, and I just added 15 minutes, well, then I'm going to add 35 kilometers. And so I end up with 70 kilometers. But we want up to 60 minutes because we want to know how fast you can travel in 1 hour. So I add another 15 minutes. And so I'm at 45 minutes. So I'm adding 15 minutes on the top, 35 kilometers on the bottom. That's a 70, by the way. There we go. So if I add 35 kilometers to 70, I am now at 105 kilometers. But still, I'm looking for per hour. So I add another 15 minutes. I get to 60 minutes. I add another 35 kilometers. I would be at 105 plus 35 is 140 kilometers. And so now I know this person traveled 140 kilometers in 60 minutes, which is 1 hour. And so therefore, the speed is 140 kilometers per hour. Again, just looking at our rates. There's a different way to do this too, a little bit quicker for some of you. This Jill can drive 15 kilometers in 10 minutes during a trip to Kingston to attend a hockey tournament. What's her speed in kilometers per hour? Well, again, in 10 minutes, Jill travels 15 kilometers. But I know that I can get to 60 minutes real quick by multiplying by 6. That'll get me 60 minutes. I can do the same thing to the kilometers, times it by 6, to see how many kilometers we'd have. So I take my 15 kilometers and I times it by 6, and I get 90 kilometers. And so that's how far they travel in 60 minutes or in 1 hour. So therefore, speed is 90 kilometers per hour. Again, that's just looking at rates and how unit rates can look on a graph as well. But now we're going to specifically look at rates. So for example, 4 here. The graph shows the average fuel efficiency for an older sport utility vehicle, SUV, my favorite, and a new smart car, not for me. Find the rate of change for the smart car. When you see this and you have a graph finding the rate of change, it's a nice way of saying find the slope, but with units. So that's what that means, with units. Find the slope with units. All right, so I'm going to do that. So my slope, again, we're looking at rise over run here. And I got 2 vehicles here, the SUV and the smart car. So I'm going to use 2 points. So again, we don't need the SUV, but we do need the smart car. Now, it actually tells me 1 point here, that if I go over 15, this is at a height of 360. That takes some guesswork out of it because I don't know if I see any other good points here. This one's pretty good. 5,120. Yeah, maybe I'll use that one. That looks like a good one. Oh, I don't think it is 5,120. Oh, it is 5,120 right here. Okay. I can use that point, and let's use the 0 point down here. And so again, using rise over run, go from 1 point to another. I move over. Actually, these blocks are worth 1 each on the x-axis. So 1, 2, 3, 4, 5 over. Now, again, when we're finding the rate of change, we need the units. And this is on the x-axis here, volume of the fuel used in liters. So 5 liters was used. We move from left to right here. We went right 5 liters. And then we're going up. Now, this is 0 here, the height of 0. And it looks like we're going up to 120. So we've gone up 120. And the units, distance traveled, kilometers. All right. And let's see here. I take my 120. I divide it by 5. And here's my answer. 120 divided by 5 is 24. And our units again, kilometers are on the top. Division is per. And on the bottom, this time we have liters. Now, we're getting into actually figuring stuff out. What does the rate of change mean in this graph? Well, our rate is 24 kilometers per liter. We're talking about a smart car or cars in general. And so the rate of change in this case is the amount of distance, or the distance you can travel on 1 liter of gas. 24 kilometers of gas, or distance in 1 liter of gas. Now, a couple of questions. And this ties into our rates, that using unit rates that we did the other day. How far could a smart car travel if it was filled with 30 liters of fuel? Well, our distance, if we travel 24 kilometers for 1 liter per liter, and now we're traveling, I'm going to put this in brackets here. We're traveling 30 of those. So I'm going to multiply by 30, because we can travel 24 kilometers with 1 liter, but now we got 30 of them. And so I take my 24 and I times it by my 30. And this person can travel 720 kilometers on 30 liters of fuel. I wish, not my car. All right, now the next one, a little bit different. How much fuel would be needed to drive 550 kilometers using the smart car? Now, this comes down, like I said, to our using unit rates before. We have our unit rate here, 24 kilometers per liter. So I'm going to make that a fraction, 24, or go back to what it was. It was a fraction up here, 120, but I'm going to have 124 over 1. You'll see what I mean. 24 kilometers, we can travel it in 1 liter. Equals. Now, I'm going to have a rate equaling a rate here, just like we did with using unit rates. The distance we have is 550 kilometers. I'm going to put that on the top because kilometers is on the top. On the bottom, we want to know how much gas. And guess what we got? Fraction equaling a fraction again. So we cross multiply. All right, so I have 24 times x is equal to 1 times 550. Well, that's just 550. And so I can just get rid of this 1. And so now I'm going to get x by itself. I'm going to divide both sides by 24. And so that will divide our 24s out. And now we're just left with x, which is the amount of fuel we're looking for. I take 550 and divide it by 24. And I get that it would take 22, again, going to 2 decimal places as usual, 0.92 liters of fuel if you want to go 550 kilometers. You want to go 720 kilometers, you're going with 30 liters of fuel. All right, let's try another one of those. So not only are we finding the rate using the graph, we're using it to figure stuff out. All right, example 5. Jocelyn's earnings. Just going to check the chat here real quick. All right. Jocelyn's earnings are recorded on the graph below. All right, there we go. There's Jocelyn's. We got pay over here and number of ads sold. Find the rate of change. So again, we're talking about finding the slope. So again, I need 2 points. I'm going to go with this one here. Again, no decimals. And the one at the bottom here. All right, so now to find the slope again, rise over run. traveling from one point to another. All right, so let's see here. Going over to the right, I move 10, 20, 30, 40, and 50. Now I'm below the point, so I've got 50 as my run. And what are we looking at here? Number of ads sold. So it looks like they sold 50 ads. I've counted over. All right, and now the rise. Going again, leaving off, starting from where I left off here. So I'm going up, up and up, 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 up. And let's see, I started at 0 here, and then I'm going up to, let's see, a height of 500. So I'm going up this purple line. I'm going up 500 here. All right, 500 what though? 500 I'll put in there. The units are dollars, $500. All right, so now I'm going to divide my two numbers and put some units in. All right, so let's see. I take 500, divide it by 50. I get 10. All right. And what are the units here? On the top is dollars. Okay, so dollars. And division again is per. And on the bottom we have ads, $10 an ad. All right, B, actually putting some meaning to it. What does the rate of change mean? Some of these are obvious and some of them aren't. We got $10 per ad. Well, this is talking about Jocelyn's earnings. She earns $10 for every ad she sells. That's what it means. Kind of straightforward sometimes, but sometimes not. C. What would Jocelyn's earnings be if she sold 110 ads? Well, she says makes $10 per ad, so amount earned equals she's making, I wish I was making $10 per ad. And we're going to multiply that by the fact that she's selling 110 of them. So we're going to multiply. And let's see here. I get 110 times 10. I get $1,100 that she's making. Now we go the other way. How many ads would she have to sell to make $880? So again, this is where I'm going to use my unit rate, where I've got $10 for one ad. We've got, she wants to make $880. So I'll put that in our other, 880. Better fix that. And we want to know how many ads. So that's our X value. Again, just using unit rates here. And so, well, we have a fraction equaling a fraction. So cross multiply. Done that a bunch. And so I've got, let's see here, 10 times X is 10X. And then I've got 880 times 1. Well, that's just 880. Now I want to get X by itself. It's attached, so the only way I can get rid of that 10 is to divide it off. And what I do to one side, I got to do to the other here. And so X is equal to 880 divided by 10, which is, let's see here, 88. And we are talking about the number of ads. So she has to sell 88 ads to make $880. So again, when we're finding the rate of change, that is telling you to find the slope, but with the units included, because the other ones were just using numbers before, but now we're actually putting some units in there, and now we're actually taking that unit rate, figuring out what it means, and using it to solve problems.